Yo, 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 yo. What's up? What's up? Welcome back. Today we're working on our OpenGL renderer for our stream intro screen. So the end goal here is that stream intro screen that we just had. We want it to be rendered kind of like on a CRT in some scenes. So if we open up maybe Blender, we can kind of show kind of our sample scene that we want to end up being able to render. So we have like this CRT sitting on a desk, and maybe like we have like the text on the screen rendering this way, which would be pretty sick. And maybe we're gonna like position the camera, etc. Figure something out like that. The problem is that we need to figure out how to actually do that. So we set up like a test version of it in Godot game engine, and that's like kind of fine, but that's not as fun as doing it all ourselves. So what we've done right now is we've started setting up like a 3D renderer in OpenGL. Right now, we've kind of gone through one stream, and we got like some sort of rotation happening around world Y if Y is up, world Z if Z is up. I don't know. We haven't like defined our coordinate system yet. So rotating around like the vertical axis, we have two planes, and there's like some sort of perspective here. You can see like it grows as it gets closer to the camera, shrinks as it gets farther away. Pretty cool stuff. And so what I wanted to work on today was there's like some problems here. One is like obviously that like this guy's like half transparent and he's not supposed to be. I want to be able to like rotate him around like arbitrary axes. I want to be able to like move the cube around, and maybe I want to be able to render like multiple cubes, whatever. And then if like from there, then we can start saying, well, how would we render like any arbitrary geometry and position it anywhere in the world that we want? And from there, then we can figure out how to like import an object that's like a little more complex like this. So that's the plan, and I think we just hop into it. I did want to say that last stream we kind of tried to derive this concept of like a rotation matrix. So recap for like how like the OpenGL render pipeline works at all. We define like a bunch of numbers that we input. Like all this really is just like data. We pass this data into OpenGL land, and for each, you kind of like define like the chunking of data. So here we're chunking in triangles, and we're saying like each triangle has 3 vertices, 3 points in 3D space, and these are the only things that we really care about. So we don't have any like extra data coming into each vertex. This gets passed as an input to our vertex shader, they call it, which basically means like run some code on the GPU for every single vertex. And the reason that it's done that way is because like GPUs can like do lots of things in parallel, so you can define like one action to be done at each vertex, and the GPU will be smart enough to like blast those out for all items, which is pretty sick. And so what we're doing is like we're transforming these vertexes that define our 2 planes. This is like plane 1, this is plane 2, via this like rotation matrix. And last stream I attempted to explain how you would like come up with this rotation matrix by yourself, and I forgot like a key part of that explanation, so I kind of like didn't get there, and so I wanted to try to explain that a little better today. So if you have like a object, or sorry, like a point in 2D, and like let's say that this point is here, and he's got position like 0.5x and like 0.7y or something. If you want to like rotate this guy like counterclockwise by some amount, you can imagine this as like rotating the whole axis, which is where I got to yesterday. But where the important part of this is, so here, let's draw the old dot and the new dot. So the old dot was like here, the new dot will be like, I don't know, like over here or something, right? Maybe a little closer. And you can imagine this dot as being like a combination of 2 two arrows, right? Or vectors, as you'd call them. You have like the x vector that's like this guy, and the y vector that's this guy, right? And these guys have lengths of like 0.7 and 0.5. Just FYI, Twitch dropped all stream qualities on 1080p 60 when you switch away from the intro screen, which is weird since you had other qualities before that. I think I accidentally hit the stop streaming button and quickly restarted, and I guess that caused some sort of like little glitch for people, which is kind of fucking annoying. Sorry about that. Yeah, so these like two translations, these are like just happen to be along the x and y axis, but they could be along like any point. And so if you rotate your whole axes like this, you can imagine like, well, you still have those two same translations, but they're like along these like new axes like this. So you have like new x like this, which is the same length. This is still 0.5. And you have like new y, which is still 0.7. That's a bad color. You can't fucking see that. New y, which is still 0.7 if this is like 0.5, 0.7. And so what you can do is you can like find the you can find like the components of x and y in your like new, like in the unrotated axes based off of these translations. And so you can like do something like trig to basically find, you have like, let's just ignore a lot of those other arrows we drew right now and just go back to like the two axes. So the y component of this guy, or sorry, the x component, let's start with the x, is going to be like, I guess we'll say, yeah, the x, sorry, I'm trying to figure out what to draw here. You have like these two axes, and the new x of the dot, as it's rotated along these axes, is going to be like this distance, right, minus this distance. Because that's like the x component of your, this is like the horizontal component of like the new thing. And then your y is going to be the same thing. It's going to be this distance and this distance. And so you can kind of like figure out, I think these two are, let me think about this. These two are additive, right? Because it's actually, what I'm drawing here is actually this and this, this and this. So like you can like add up your two y's and like add up your two x's and you get your rotation matrix. So that's why you have this guy's like a cosine here. So you have like cosine theta, and this is the same angle as this, just like by like, you can like figure out this is like 90 degrees and then like this is like split halfway. Like these end up being the same angle. And so now you have like sine, because this is opposite. So you have like negative sine theta times the y height. Yeah, the times like y. This is the old y. So you can do like cos theta to get this, negative sine theta to get this. Add those up, you get the new x. And then on the y side, it should be sine theta times like the x distance, which is like the hypotenuse here, and I guess probably plus cos theta. And let's just double check if we got that right. Rotation matrix. Yeah, there we go. Cos theta, sine theta, negative sine theta, cos theta. We got our negative and positive flipped here, but then that's because here he has negative theta in here. So easy peasy. So just want to make a little bit of that. And let's start trying to render the cube. So what we had right now was two planes like this. And so I think probably what I want to do is I want to like color the planes according to their x, y, and z positions, and then add all all 6 planes that make up our cube, just so we can kind of call this guy done. And so let's adjust our fragment shader. His output right now he's outputting only his depth to the fragment shader, who does like coloring per pixel for each triangle that's drawn. So we're just gonna like say, well, let's take in our 3D position in space. So we'll say we'll take in like a position, and this position will be in like OpenGL coordinates. No, they're going to be in object coordinates. And so those object coordinates, I think right now just happen to be like -1 to 1. So we'll just scale them before passing them in. And here we'll just pass out our, oh my God. Fuck. Twitch wants to run an ad because it thinks my stream restarted. Even the pre-roll is off already. How do I like skip this one? Oi, oi, oi. It might not let me. Shit. Can I like turn this off? Sorry, this is really annoying. Oh. Okay, I guess I just have to let it run, which is annoying. Sorry, guys. Okay, sorry. So what were we talking about? We were gonna take our position and pass that as an input to the fragment shader. So we say position is out color. Here we have, sorry, in our vertex shader, we pass our output as a vec3. And the color is just going to be the input coordinate, the input vertices scaled down to the range 0 to 1. So that's going to be invert times something times 2. No, plus 1 divided by 2. There we go. So you get from the range 0 to 1. Sorry, -1 to 1 to 0 to 1. Actually, I guess that the vertices are in the range -0.5 to 0.5. So we think we only have to add 1 here. Okay. So, and then in our fragment shader, we just take that position and use that directly as color. And that's hella fucked up. Wow, that's crazy. I wonder what we're doing to fuck that up so badly. That's interesting. Interesting. So here he takes in position. I guess we'll call it color. And cannot construct vec4 from non... Oh, I see. We forgot to rename this. Okay, there we go. I guess names... I guess the naming between the vertex and fragment shader need to match up. But that's good. So now we have like individual planes, individual coloring that we can keep track of. And now we can add in all of the different sides, which would be something like going into our definition of vertices in the cube renderer. And I guess we just have to cover all of the different ones. So each plane is made up of 2 triangles, and let's see. I guess we have to draw which ones we've done already. Or maybe we could like do this in some form of loop. So we can say let data is a vector. And for x in, I guess we have like on each axis we have 2 vertices, essentially. We have -0.5 and 0.5, right? And we need to do every permutation of those on all 3 axes. So we just say 7 ads, that's rough Twitch. Dude, I'm so sorry. That's fucking annoying. I wish, yeah, I couldn't figure out how to like cancel it fast enough, so that sucks. Verts is what I want here, and then we can say for x inverts, for y inverts, and for z inverts. Then I think we can probably hit every combo. I guess this probably doesn't give us enough, because we actually need to draw each combo twice. Hold on, let's draw this out. So we have like, if we were to do X and Y, we would need to do this triangle and this triangle. And I'm trying to think of like, how do we automatically generate that? And it's like, well, I have like, if I iterate over X first, I have this and this. And so for each X, I need to do both Ys, which is fine, right? X, which is like 2 iterations of the loop. So we go for like X, Y, Y, X, Y, Y. That actually doesn't do what we want. Fuck. So maybe generating them procedurally or like with these loops is not going to be straightforward. And maybe we just have to manually define every triangle. There must be some way to like do this automatically, but I'm not seeing it, so. Why not just download data for a cube? Yeah, I guess we could do that. I guess, yeah, we are gonna have to figure out how to import objects from Blender at some point anyways, so we might as well do it now. I'm okay with that. So let's just do that here, because I don't want to manually punch things out. Okay, so yeah, let's just do that. So we'll new general, we have a cubed, and we need to triangulate the faces. For now, we're going to assume right now that we can only render triangles. We can export this thing as, we have to pick a object, like a representation. And the only thing I've looked up before right now is wavefront.obj, and it looked like pretty straightforward, like the way they define their object. So let's just pull this guy up. Wave or obj file format 3D Wikipedia. So it seems like pretty straightforward. Essentially, like each line specifies whether like a data type. So he says either I'm like a vertex, a texture coordinate, a normal, or some like VP is like some like special extra thing. What was this? VP, I can't remember. Polygonal, oh, sorry, parameter space vertices, free form geometry statement. So I think that we don't need these, but I think they're like lines. Like, I think I saw a picture somewhere when I was looking this up before. I don't see it. Maybe it wasn't on Wikipedia. But it's like, I think it's for like annotations and stuff like that. And then like faces, which are like kind of like combinations of sets of vertices. So you might have like, you know, if I have I have 4 vertices here, but 2 faces. So I specify like the vertices first, and then when I want to render a face, I can like index these, say this is like 1, 2, 3, 4, and then I can define my faces like 1, 4, 3, 1, 4, 2. Great. And yeah, that's like a pretty straightforward format. So I think writing a parser for this should be pretty straightforward. So, and probably we could import, like just like use a library to parse it for us, but we won't for some fucking reason. Because it's more fun to do it ourselves. Okay. What are we working on again? Stream start screen. And we'll put in this as like cube.obj. Okay. So let's figure out how we're going to parse this thing. So we'll make source like obj parser. Maybe parser isn't like the right thing here. Maybe we'll just call it obj file or something. But we'll figure it out later. We'll rename it later if we need to. And so we import that module, obj parser, and we're gonna have like a struct that's like an obj representation. But I guess it's not really, we don't really care about the fact that it came from an obj. Really, we're just gonna want to like have this be a mesh, is what they call it, like a 3D thing, and it just happens to come from an obj. But that's okay for now. We'll call it mesh. This probably isn't the right spot for it in obj parser, but whatever. And right now we're gonna kind of like structure this mesh. We don't really know what other mesh formats might be, or like how we're gonna design our meshes. So for now, I think it probably just makes sense for our mesh to match what we expect to see from this like file format. So in here we can say vertices, right, is gonna be a set of, looks like 4D points. We haven't really, I can't remember if we've covered homogeneous coordinates yet, but the generally like the format here is you have like XYZ, which is your like 3D point, plus like a scalar essentially. So if this is like 0.5, everything gets scaled by 0.5. And there's like nice mathematical reasons why you might want to do that, but for now we're not going to worry about that. We're just going to assume that this is always 1, and that's what this is saying here. It defaults to 1, and so we'll just assume it's always 1 for now and deal with that later. That'll become important in like projection and stuff, but for now we'll assume it's 1. So we'll have vertices. So these are all going to be arrays of 4 floats. We're going to have texture chords, which is going to be arrays of 3 floats. We're going to have normals, and this is like very, very, very unimportant for us right now. Because we don't have like any form of lighting or anything, so we're not going to really use this, and really we don't need texture coordinates yet either, because we're not going to do any texturing yet, so maybe we're only going to do vertices and faces. And these faces are going to be, each of these could be arbitrary length, each face. So I guess each face is going to be a vector, like our face is going to be a vector of u size, right? Indexes into the vertices. Yo, what's up? So now we're going to make a way to like parse this guy. And then we're going to need a way to like render him. So I guess we can do the parsing first. It would be kind of interesting. We could do the rendering first and like take our existing double plane rotation and like shove it in this file format, but maybe it's fine to do the import first. Both are like independently verifiable, so I'm not really worried about it. And so maybe we'll say function from obj file. It's not arbitrary length, it's either 3 or 4. Most GPUs. I thought that you could export polygons though, and we have to then like triangulate manually internally. Although theoretically, I'm not going to support anything that's not triangulated initially, so I could like force it to be 3. But it looks like each face can contain 3 or more elements. But yeah, you're like, I can save some sanity by parsing only triangles. Yeah, I was actually looking at this earlier today. I was looking at triangulation, polygon, something like this. Yeah. And there are like algorithms that you can do to like convert any n-gon into a bunch of triangles. But yeah, I think you're right. I think you're right that saying that these guys are all going to be 3 like triangles for now will save me some sanity, and when we parse the obj file we can just assert, like we can just fail to load it if it's not 3. I agree. So the file I guess we'll take in something that implements read, I guess, right? It doesn't really have to be a file necessarily. We could pass in a buffer here, which we might. And we're going to say that the reader is R, and we're going to return a mesh, and we're almost certainly going to be able to fail. So we're going to return a result mesh, result mesh, and like obj parse error, I guess we'll call it. Which means that we need to have a pub enum obj parse error, because I'm going to assume there's going to be multiple ways that this guy can fail, and I guess, you know, just for completeness, we usually derive debug and error for this guy. And for now, we'll say error, obj parse error. Okay. What is this project about? We're trying to just do some 3D rendering. So we have this scene in Blender / also in Godot, and we just want to render something like this, but on the fly using our own OpenGL renderer. So we're kind of like piecing together the pieces that we need to do that. Okay, so I guess we're going to split up our reader by line, right? Because, well, I guess actually before we do make any assumptions, let's like just fucking open the thing that we made, because like I don't actually know. Like, we're reading on Wikipedia, but who knows what it actually looks like. So, where did I fucking put this guy? Here. Okay, so this guy is very much like what we expect to some extent. They have materials in here. They have some like prefixes. We have some prefixes that we haven't seen from that Wikipedia article that we're gonna have to. Maybe we'll just discard them. Maybe. Maybe these are grouped by object. But for now, let's just parse vertexes and faces, and maybe we'll come back to the extra stuff later. So reading a model and rendering it. Yeah, that's where we're starting. Plus like some like shader stuff, and we'll eventually have to do like some lighting as well, and like I don't know. It depends on how good it looks with how little we can implement. Okay. So, well, I would like to know. Does this here? Okay. He also says that there's. What is this, like mtlib? mtlib. Materials. Oh, okay. So they have like external materials that I guess were exported here that have some parameters. So we'll ignore that. Use material and objects are specified with the following tags. I see. Okay. So I guess we'll start by materials fucking suck. I wrote a parser for it and there's so much stupid stuff. Yeah, I'm almost certainly not going to do that. Because like anything we material in Blender, assuming that like I'm the only consumer of this, anything that we material in Blender, we should be smart enough to implement like in just like raw fragment shaders and stuff. So I'm not really worried about that. I'm more worried about getting like geometry out of Blender, because that's kind of like the hard part in my eyes, is like specifying every vertex. You know, it's a lot harder. Are you using GLSL shaders or is there a Rust EDSL? I'm just using OpenGL, so GLSL. But there might be something that you could use in Rust, but I would imagine, my understanding of like the graphics world is that anything that you write is just gonna like compile down to Vulkan or GLSL under the hood anyways. Like every game I've ever seen says like, oh, we're gonna use our OpenGL backend or our Vulkan backend. So it's like I don't really know why I'd like throw extra layers of abstraction on top, except for like the name of cross-platform. But I don't care about that right now. Yeah. Okay. So I guess for each line, we're gonna want to like split this up by line. So I think Rust there's like a read trait, which is like I can like, what am I typing? Read. I was trying to type trait and Rust at the same time. That's pretty funny. So there's like a read trait, which will let you read like chunks of data, but there's also like a buff read trait, which lets you chunk by lines, because the idea is that like buff read has an internal buffer and it can read until it sees a new line and then give you the stuff up to the new line and like save the rest for later. So let's actually say that this thing has to implement buff read. And we're going to split by line. So for line in our lines. And then we're going to check if what the first character is. I guess we're going to split by space as well. So we're going to make like an iterator, I guess, for each thing for each line. So we'll say let line iter is equal to line dot. What is line here? I actually don't know. Line is. Oopsies, let's throw an unimplemented in here so that the indexer works correctly. And line is a lines which puts out strings. Yeah, okay. So line dot. Oh no, it thinks it's an option. What the fuck? Am I high? Am I high? Lines implements iterator. Oh, each thing is result. Because I guess you could error out before you finish reading the file. Okay, so we'll just say for now, let line equals line dot expect failed to read file. I guess we could do proper error handling here. So we'll say map error obj parse error file read. And we'll say here that we have like a file read with an inner thing of like a IO error probably. So we'll have to pull in error as IO error and shove that in here. Cool, 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 cool. All right, and so then we can split, we have like a string in here, and we can probably split our string by white space or spaces. So there's probably some like split, here we go, by some pattern. Yeah. And there's a split white space, which does it for us. Nice. So we'll say for, let line iter is equal to line.split white space. And the first thing that we see is going to be like the character that defines what type we're looking at. So we'll say let type is equal to line iter.next. And if our line doesn't start, if there's like nothing in the line, I guess we're done. I guess we'll say if we don't expect any trailing characters on here. So we can say that we'll get the next thing, and if we don't get it, we'll say missing obj parse error missing type, I guess we'll call it. And here we'll just say obj parse missing type. And this isn't a mapped error, this is an option, so we'll just say okay or. And if it's not there, we fail because the thing doesn't work the way we expect. And then depending on the type, we're going to parse this thing differently. So we're going to say match type. And if we see V, we do something, right? If we see F, we're going to do something, F for face, V for vertex. And anything else, we're going to say print line unsupported type, and we'll log it for now. And probably in the future, we'll just ignore this. Like, this being like a print is probably wrong. We should probably like debug log this or something because we know that we have things that we don't support, or maybe warning log. We don't have a logger set up, so we'll just do this for now. For the vertexes phase, we're going to say, what? We're going to say let vertex is equal to parse vertex from the line iterator. Right, and almost certainly he's going to be able to fail, so we will put a little question mark on him. And assuming that works, then we're going to say we're going to have to push that vertex back somewhere. So we're going to have to keep track of all of the available vertices somewhere. So we'll put that up here. And we're also going to have to keep track of the faces. So we'll just shove that here too. And then here, we're going to say vertices.push vertex. And we're going to do the same thing here, but with faces. We're going to parse the face. And faces push. Then down here, we're good, and we can say, we're just going to return the mesh. We're going to say mesh with vertices and faces, and we're going to have to write a little okay here. You ever read a function so clean you gotta get up and do some shadow boxing? Yeah, you just like start feeling yourself. You're like, it's just like, oh. Sometimes it feels good, man. Sometimes it feels good. Okay. So to parse a vertex, we're gonna take in our line iterator, which is, I guess, I actually don't know what this thing is. Split white space returns, it's an iterator that returns strings references, which makes sense. So we're going to take in an iterator who is an iterator where item is stir, and we need a lifetime associated with that, I think. So we have to put a little not ampersand. What am I talking about? Single quote A to say there's a lifetime associated with this guy, and he's going to take in the iterator, and he's going to return. I guess what do we say our vertex is? 4 floats. I forgot to put a little bracket here, and we're going to do the same thing for parse face. And here, these guys are both unimplemented, which means that this should compile now if we got everything right. But we did not, because the face has to return F323. And these guys, we said they were going to be failable, so we're going to say result, and their fail type is an obj parse error. Sick. So these guys said he expects a single float. So I just forgot to put vectors for both of these. And my faces being sets of floats here was also just totally fucking wrong. These should be sets of view sizes because these are indexes into the vertex vector. I don't know what I was thinking. Lifetimes were the hardest feature of Rust to learn for me so far. Dude, they suck. Like, they're what enable what all of the things in Rust that I like, but holy shit. Like, if you come from, like, any other language and you try to, like, use a reference in a way that, like, Rust doesn't like, that's one of, like, the hardest hurdles that I've had to, like, figure out in programming as a whole. It's, like, it's so hard to, like, reframe the way you think about everything, and the syntax around them fucking blows. So it's just, like, double whammies. And there's a bunch of, like, implicit shit. So if you do, like, function, like, do something, and he takes in a reference to, like a string, and he returns a reference to, like, something else, or, like, how do I say this? Like, if I, like, say, I'm going to take in a reference to string and return a mesh that references a string, you, like, can, like, put in these inferred lifetimes, and then this guy that comes out, he just, like, has the same lifetime as this, and it's like, how is, like, I get that you're, like, trying to help me, but, like, as a new person trying to learn the language, you'd, like, lose your fucking mind. Like, I can't, yeah, lifetimes blow. But they also rock because, you know, it's how we get what we need from the language. But if the language could do all this without lifetimes, holy shit, would that be nicer. Alright, sorry, aside. Okay, so we compile now again. Cargo check. Very nice. And now let's just start stubbing out these, like, parse vertex and parse face functions. So parse vertex, he's going to expect 3 or 4 things, right? So he's going to say it next. How do we want to do this? We could say for I in 0 to 4, we have let mute result is equal to 4 zeros of F32, and we're just going to reassign them, I guess, based off of the index here. And I guess we're going to do 2 sets of things. We're going to do I 0 to 3, where if this is not available, then we say okay, or obj parse error missing vertex. Right, because it's guaranteed to have 3. And on the 4th one, we just do the last one. So we would say the 4th vertex is this guy, and in this case, it's not an error for it to be missing. They said it was optional, so we can just say unwrap or 1.0. And then we return the result. Cool. Cool. So we need the new object parse error, which is missing vertex. And then this guy needs to be wrapped in okay. Do I have to write F32 here? No? What doesn't he like here? Expected due to the type of this binding. Hello? What am I missing? Cargo check. Found stir. Oh, because I have to fucking parse. Okay. So here I have to say parse. And here we could fail to parse that as a float. So we'll map the error and say float. I guess we'll call this obj parse error not non-float vertex. Yeah. That seems too small. And non-float vertex will have some sort of internal error that's mapped from, like, stood Stir parse error, parse bool error. Maybe it's F32 parse error. How do we parse error? Stood stirring parse error. That seems reasonable. Oh nope, that's not what we want. Where's the like num parse error? Parse int error? Oh, parse float error maybe? Parse float. Yeah. Stood num parse float error. That's what I'm looking for. Stood num parse float error. Nice. And here we have to do the same thing for the last guy. So here, I guess we could just write 1.0 so that our chaining works, which is kind of stupid, right? This isn't how we should do it. So I guess we try to get the thing. If we get it, we parse it. So we say, and then, not and then. I guess we'll do like a little match statement here. That'll be a little easier. So say match it dot next. And if we get something, we try to parse it. And if we get nothing, we return 1.0. There we go. Put a little comma. Cannot borrow as mutable, so we throw a little mute on this guy. Bang, bang, boom. Cool. Cool. Hello, I think I'm very late. Can you explain what you're doing? Yeah, we're just trying to import a cube that we exported from Blender. And then we're trying to render it with OpenGL. And the reason we're doing it this way is because I didn't want to type in 8 vertices. So we're writing a parser for an object file because in the future we're planning on like importing like some more complex geometry like this CRT or something. And so might as well do it now. Okay, so that is our vertex. Now our face is defined as he starts with an F, and then he's got like some slashes in there. So let's kind of figure out like what the fuck is going on. So he has the vertex slash the texture slash the normal. So in our case, we can expect that there may be some things after the slashes, but we only ever care about the first one because we only support, say, like the vertex one right now. So what we can do here is we can say we're going to iterate the thing, and we're going to take until the first slash or the end of the thing. So I guess we can say it for item in it. We should see 3 faces. So I guess first we can say, are there 3? I guess we don't know until we get to the end of it. So so I guess yeah, that's fine. So what's our return type? Our return is 3 U sizes. So let's start there. 0, 3. And we're going to say for I in 0 to 3, we're going to get the next item. So we're going to say it.next, okay, or obj parse error missing face vertex, I guess we'll call it, right? We are expecting a vertex index for our face, but he's not there. Okay, reasonable. Why isn't my indexer bitching at me? He should be mad. LSP info. He says running. Target check. Yeah, he should be like, hey, that doesn't exist. Something must be missing. There we go. That's what I want. I want you to yell at me. Thank you. So we have missing face vert. So we just kind of shove this guy in here. In our types of errors that we can have, our iterator needs to be mutable. Very nice. And what are we going to do with this thing? We're going to split it. We're going to split it by slashes. So we're going to say face split I guess we'll split by this pattern, which is just a slash. So we'll say let face iter is equal to this. And I think he has to be mutable as well. And we're only going to care about the first thing. But in the future, we could have cared about the other one. So we'll just say let vertex ID is equal to this iterator, the next thing in it. And if we don't find it, we'll say, I guess that's still missing face vert. Now, I don't like the fact that we're reusing the error, because when we see this error, inevitably, it would be nice to like pinpoint exactly what went wrong. But like both of these are a missing vertex, but they're kind of missing in different ways, right? The first thing is we're missing like the chunk, and the second one is we're missing like the first thing. I guess this should never ever fail, right? If we have something and we are iterating over it, if there were no slashes, we should still always get the first thing. So we can probably actually say that this is an assertion that says first element doesn't exist for obj face. And I'm pretty sure that that's okay. There might be like some edge case here that I'm not thinking of, like maybe like a 0 size string, but overall I think that's okay. Okay, and so then our ret I is equal to vert ID, right? But we need to parse this thing as a float. And so we'll say map the error to a parsed error, but the parse error is going to be invalid face vert. Okay? And then we just return ret. Say we are good to go. And then all we have to do here is shove this guy in here. So what did I call him? Invalid face vert. And he is a std num parse int error, probably. Nice. Consider using an iterator. Item, and I don't, that's fine. I don't really care. Clippy, shut up. I'll deal with you later. Can you construct an array in Rust from an iterator? Let's say if I don't want to use mute. Yeah, I'm pretty sure you could do like iter map like x to y and then like collect. And if you collect this guy as an array, he'll probably do the right thing. I don't know about if you're trying to like map directly to an array. What if like your iterator isn't the right size? There's like some sort of runtime check there that I'm not really quite sure about. But usually you can. You could do like maybe like that would probably make a slice, and then oh yeah, that would make a vector. Yeah, you're right. And then you try into yeah, you could, but in my mind, this works better. So, you know, not better objectively, just like better for my brain. So it's fine by me. I guess why the fuck not? These are like incredibly unit testable, so we might as well huck a couple at them. Test. We'll say test vertex parse. We might as well. And so what are the types of things that we can pass into here? So we have like a few types of failures. We have non-float vertices, and we have missing vertices. But otherwise, we should be able to pass in anything, right? So we should be able to pass in like this, and this should like not crash, but it should give us like an error. So, I guess this guy needs to be converted into an iterator. So we'll just say split white space. And we'll say assert that this is equal to obj parse error, like non-float vertex, I guess is what this will be. Right? This should fail, and this would be an error type. And I think for this, like, assert equal to work, we have to, like, derive error EQ on that guy, but we'll see. Cargo test. What does he like? First, we need to import everything. And, yeah, he needs this guy to implement... Oh, wait, who doesn't implement debug? Cannot be formatted. Function parse float error. What is he bitching about? Cannot be formatted using debug. Why is it trying to log a function? Am I high? Oh, because no, I'm not seeing. Use parentheses to construct this tuple variant. Okay. Oh. I see. So this is going to be like, it's going to have like something inside, but I don't really care what it is. Is there like an assert matches in here in Rust? Assert matches. Nightly only. Fuck. All right. We'll write it manually. If let, I guess we'll say match this guy. Okay. This is assert panic, I guess. Invalid vertices should not parse. And we have an error. And if our error is an obj parse error, invalid vertex, non-float vertex, I guess, we're happy with this. Nothing to do. And otherwise, we say panic, unexpected error type. Okay, and we can maybe like add some granularity here, so we can say test vertex parse invalid float, and we could do like a couple of these where we expect like even if we were at 1.0 for the first one, we get an invalid float for the second, and maybe we do. I guess we can parse the valid one separately, so we'll make a new test. It's like test valid vertex parse. And we'll do 1.0, 1.0, 1.0. I guess we should do 1, 2, 3. Any error is a unexpected failure. And if we succeed, we should see assert equal that our return value is the same as 1.0, 2.0, 3.0. Now, obviously, this is like fucked. You can't do this because floating point representation is like not really deterministic. So I guess for each of these, we have to like compare that they're close. Is there like an assert close Rust? Relative EQ and approximate. Fuck it. Okay, fine. Oh my god. So we'll say let expected is equal to 1, 2, 3.0, and then we say v into an iter. The thing we got, we could put it into an iterator. We zip it with the expected values, and say for a b in this thing, assert that what a minus b, the absolute value of it, is like less than some delta. Jesus. Awful. Awful. And we forgot to say that this is a test so that it gets run. Okay, both of those tests pass, and just to double check, if I put like a 2 here, he will crash and say like, oh no, that's not what I expected to see, fuck. Okay. And I guess there's like other failure types here, right? There's the, we should test the 4 vertices as well. So if we see like 2.0, say like they give us 1, 2, 3, 2, this should actually get halved, right? Because these are like homogeneous coordinates. So each of these should get set like this. And we almost certainly didn't implement that. So that's actually going to fail. Yep. So I guess our vertices, our vertexes are, we don't have to handle that here. They're four-dimensional. So this should actually be 2.0 like this, and this should be 1.0. There we go. There we go. And then check here, this guy, throw a 2.0 in there, and he fails. Nice. Cool. Okay. That's good enough for now. And I guess we can like throw a quick test for the faces as well. Man, doing things right really makes it take longer. Have you guys ever noticed that? So test face parse. We'll do maybe a simple case where we say parse face and we have like 1, 2, 3. Say no slashes. Right. And we'll fix me like do something with this. I just kind of want to like stub out the different types. We'll make another one that's with slashes. With slashes, so we'll say 1, 1, 2, 2, 3, 3. And we'll do it again with doubles. Test make everything longer. Like in some worlds, like by some metric, it makes it so that like it makes like long term faster and like bug hunting faster, right? Like sometimes you skip them and then you spend an hour chasing down like a really simple to find bug. But yeah, I'm probably going overboard here. I probably shouldn't waste my time with this, but you know, sometimes you just do it just because. Test face parse, not enough elements. So here we'll try 1, 2, and then we'll throw in a valid parse, which we already did. I guess we'll throw invalid index. So here we'll just like throw in like a 1.1. And maybe we throw in a ASDF or something. Okay. So here we expect this guy to be okay. We expect him to pass. And we expect the value to be the same as 1, 2, 3. Easy. Panic. Unexpected face parse failure. Yep, like this. I forgot an arrow. Here we expect the same thing, so we say, can I like copy this, paste it here, replace the function call with this, and this should be the same, and this should be the same. So 1, 1, 1, 2, 2, 2, 3, 3, 3. This guy should fail with not enough elements. So OKV goes to panic face parse should have failed. The error should be obj parser you're missing face vert. Yeah. But anything else? Anything else should be panic unexpected error for face parse. There we go. And the last one, we have something similar, but this is this guy. Boom, boom. And his error should be invalid face vert. Nice. And that should be the same for this other one, actually. Easy peasy. All right, cargo test. Moment of truth. Shockingly, all of those passed. Which is pretty sick. Pretty sick. Okay, so I bet now if we threw our object file at this, we'd probably get something kind of sane. So let's go to main, and let's say somewhere we're going to parse our objects. We're going to say let obj is equal to obj parser mesh from obj file. And I guess we will maybe include bytes the object, which is cube.obj. And he doesn't like that because he's up a directory. And convert the array to a U8 slice like this. Okay. Let's pull this together. So he's saying that this guy doesn't implement buff read. the trait buffer is implemented for and U8, but not for and U8. So why the fuck did it tell me as slice, maybe? There we go. So that runs. It's got a lot of unsupported types in here, but otherwise it looks like it's running, and we can maybe like print this guy and see what we got out. Which means that this guy needs to derive debug. And why didn't he print? Oh, there we go, because I didn't save. So here we have our different vertices. Nice. We have 1, 2, 3, 4, 5, 6, 7, 8. Nice. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 faces, which is 6 times 2, 2 triangles for 6 faces on a cube. That looks pretty sick. Looks like the object parsed probably correctly. And now let's, maybe I just want to go back and scale the cube down a little bit because our OpenGL renderer doesn't really handle that quite right. So we'll go back and we'll make a new thing and we'll just scale this bad boy down and triangulate him and export him again. One more time. So he is going to go over into our stream start screen as our cube object. And let's run him again. Cargo run. And now our vertices are smaller. Bing, bang, boom. Okay. Now, all of that means that, so we have our like object is imported now, and now we actually have to like render it. So we'll say render imported mesh. Okay. Blender has an X in the export dialog option called triangulated mesh. Yeah, that doesn't surprise me. I don't know. Same thing as hitting tab and hitting Control T. One of them feels faster to me. Doesn't really matter. But good eye, good eye. Okay, so this cube renderer is actually going to start being something like kind of more interesting. We actually want it to be like a generic mesh renderer now. And so I guess like you could pass in the mesh as an argument here. Does that make sense? Or you could pass it in at like construction time. I think I'm going to do construction time now because that simplifies something in my head. But in reality, probably we should have like one renderer class that renders multiple different objects, and the objects are passed in and like as arguments. But then I think I need to introduce a new type to handle that correctly, because you would need to like track the upload of data from you would have to like first import the data, then convert the data into like OpenGL buffers, then pass those OpenGL buffers in. And I don't want to deal with that. So I'm just going to say each cube renderer will render a single cube or a single mesh, and then we'll fix it later because this is a faster way in. So we'll say we take in a mesh where mesh comes from use create ob parser mesh, which is the wrong place for that, but I don't care right now. He's going to take in probably like a reference to a mesh, because really he's not going to like he's not going to like hold the mesh forever. He's only going to use the mesh to generate the like needed OpenGL buffers. Okay, that's reasonable. And so something that we haven't looked at yet is OpenGL has this like concept called an element buffer, I think. Which is very similar to the like vertex buffer that we were talking about before, except it specifies like indexes of vertices to draw in a face. So this is actually exactly the same way that like this guy is formatted here, right? He takes in indexes of vertices. So we create our vertex buffer, and instead of generating a cube buffer, what we're going to do is we're going to take the vertices in our mesh, and then we're going to have to like say let EBO is equal to gl create element create buffer, and unwrap this for now until, because we're not going to deal with errors yet. Then we bind the buffer as a element array buffer. Yeah. And then we like upload the mesh face indexes. So I think that probably we can actually just bind these guys almost directly. Because right now we're not doing things else. So I think we can say we're going to create a buffer here for the vertex buffers. And we can just say probably bind this shit, baby. So we can say here we have an array buffer of mesh dot vertices, which is not a public thing right now. So we'll just quickly fix that. So we have mesh vertices, and here we need to we have like a vector of 4 floats packed together, which should turn into the same thing as a vector of floats. But I don't know what like the way to cast that is. I guess it's we'll replace this F32 to U8 slice with vec F32 vec F32 array to U8 slice, and his input is going to be like some relative to the number of elements in each array, which I think you say is a U size here, and then you can say the input is I guess we don't need we can say that we can work with slices instead of vectors. It doesn't have to be a vector. We're going to have a slice of F32N, and he's going to cast to a U8 buffer, because that's like the way you upload to the GPUs. You like just give him a pointer and he'll cast it back. So we'll say slice of F32 arrays to U8 slice. And I think that that'll probably work. Maybe. We'll find out. So you'll say slice F32 array to U8 slice. And we put a little ampersand on here. Cool. And I think before we get to this like element buffer, I do just kind of want to draw this and see if we see something. Because that'll give us a clue. It won't look right, but it might give us a clue if we have vertices in like approximately the correct positions. So our cube renderer is going to take in our object now. So our object is going to unwrap, and we're going to pass in the object here, maybe as a little reference on him, and let's see what we see. Okay. Maybe. 1, 2. Yeah, that might be right. I'm gonna stop rotating it real quick. Which I think we had in main. We were like incrementing our camera position relative to time delta. I would like to see, like, some of these look like they're like pretty far off screen, and we're also not rendering the right amount. So let's make sure that we're rendering the number of vertices we expect to have. So where am I? I'm in the wrong file. Cube renderer. And we should have I guess we need to keep track after we import this guy of like how big he is. So we'll say let num vertices is going to be a U size, right? And our number of vertices is going to be the mesh vertices.len times mesh vertice, like stud mem size of val mesh vertices 0. Yeah. With a borrow. And then we store that guy here. store him over here, and then use him over here. All right. So he doesn't like this, so we'll say try into dot unwrap. Okay, so let's check a few things. We need to check a few things. So let's print out all of the inputs again. So we'll just print line mesh. Oh, fuck, because our vertices are 4-dimensional. Right. So we need to adjust our vertex array object, or sorry, our vertex shader, to expect inputs with 4 vertices. And that also means that when we set up our attributes, that we say like, hey, here's where the data is, we need to adjust to say these are 4, and stride is 4, and our inputs are 4. And we'll just ignore the last element for now. So we fucked up because someone did a assignment of a 3D to 4D. So this is probably this guy. Okay. That looks a lot more reasonable, maybe. I guess it depends. Like, are our vertexes in the right spot? Maybe not. Let's turn back on rotation and kind of see what we see. It's possible that there's like some alignment that we haven't taken into account. Very possible. Some of them look right. For sure. Right, like we can see pretty clearly that like right here we have squares forming with some of these points, but the triangles are kind of like matching to the wrong vertices. The only one I'm worried about is there's like one that's like in the center that I feel like shouldn't be there. But otherwise it looks pretty good. So it might be worthwhile now trying to use the faces correctly. And then from there, we will have a better idea of like what's actually fucking broken. I think. So let's make our element array buffer. I don't know what you have to do to use these. I can't remember. Is it like GL draw elements, maybe? Yeah. So we specify our element buffer, and then we specifically ask OpenGL to draw it as this like index of vector indices, or index of vertex indices instead of the vertices directly. Is my job also Rust related? Well, I am currently on, we could call it a sabbatical if we wanted to get really fancy with it. I'm not working right now, by choice. And so if you consider this my job, then yes. But I've never really had a job that's Rust. It's just kind of something I've picked up on the side because it's like I've done a lot of C++ at work, some Python, some web, but like mostly C++. And Rust is like, if you're in the C++ world, Rust is just like, mwah. Well, depending. There's multiple areas of C++, right? Like, I'm sure game devs aren't really, as a whole, too thrilled with Rust. But like people who are like into like modern C++, what they call modern, like C++ 11 onwards, the Rust stuff is like kind of just like a better version of that in my eyes. So kind of fits all the same gaps while removing some of the like bullshit from C++. I don't know. It's a fun language. I like it. But it's not for everyone. What was I trying to do? I was trying to make an element array object. So we have to bind this guy. So we're going to do the same thing here, where we bind this guy as our element buffer, and then we upload element array buffer with the faces. Arguments this function are incorrect. So I thought that this would work for any n. Cargo run, like what's it bullshitting about? Found vec u size 3. Oh, because it's not an F32 array. It's a u size. I guess we could say slice array to u8 slice, and we'll just shove a t in here. T for anything. Okay. And slice array to u8 slice, we can do that for both of these guys. There's quite a large group that prefers Go. I could like assume that the group of people that prefer Go are the same group of people that would prefer C to C++, but I could be wrong about that. But that's always been my feeling. Okay, so now, hopefully, I should just be able to say, instead of draw arrays, draw elements. And num vertices, I wonder if this is the same thing. So what does this guy take in? He takes in the type of thing we want to draw, so triangles is still fine. Count the number of elements to be rendered. So I guess that's the size. Instead of saying storing the number of vertexes, we should store the number of elements. So we should say num elements is the faces length times mesh vertex faces 0 len. I think that probably makes sense. And here we store num elements. And here we store num elements. And here, when we draw the arrays, we draw num elements elements. The type of the values in the vertices must be unsigned byte, unsigned short, or unsigned int. Oh, fuck. Ours are none of those. Ours are U sizes. So I think that if we were to just use these as is, we would see a bunch of leading... We would see every other vertex as vertex 0. So just to make my life easier, I'm just going to say that these are U32s instead of U sizes. And everywhere where I worked with faces, we could say U size goes to U32. And I think everything else, wow, I like it when like all the types just kind of propagate for free. That's kind of sick. That is sick. Okay, so now we have U32s and everything should just work the way we need it to. And so the type now is going to be GL unsigned int. Like this. And what's the last thing? Specifies a pointer location where the indices are stored. So we'll just say start at 0, please. Okay. Cargo run. We need to specify some shit even though we're not using it right now. That's really damn close. Right? That's not far off. I swear like one of our vertices or some of our vertices are at 0, 0, 0 when they shouldn't be, which is kind of odd, right? Like this is not. Is it possible that I'm doing some sort of like conversion in my vertex shader that I shouldn't be? Oopsies, we're looking at the 3D vertex shader, and let's not invert XYZ. Let's see. So I think that we have some valid triangles in there, right? Like this guy here looks right to me. Some of them are going across the diagonal on top, which is just like totally wrong. Maybe there aren't any that are going through the center. That might just be two intersecting triangles. So we could be maybe off by some amount. Okay, let's simplify. So let's take one quad. This quad. And let's only make a single face, or we'll update our cube to only have faces that work with this quad. I guess maybe this one's a bad one because it goes along Z. We kind of want one where Z is constant. So we're going to look at vertex 0, 1, 4, and 5. Okay? That seems reasonable. So we're going to say 0, 1, 4, and 0, 4, 5 should be our two triangles. And that maybe we will get some sort of intuition on what is not working at that point. So that looks like maybe right. 0, 1, 4 and 1, 0, 4, 5. What are those two? 0, 1, 4 and 1, 4, 5. Was that what we did? We did 0, 1, 4 and 0, 4, 5. Maybe we did 0, 1, 4 and 1, 4, 5. Sorry. Yeah, okay. So that's a functional quad, right? That just is like correct. And it's possible that like we're not handling our Z position correctly in our vertex shader. Outvert xz is equal to the rotation. And then we scale our xy by the Z distance. But do we scale the Z? And should we scale the Z? Probably not. Okay. Let's try, I guess we can try another quad in here. We can do 0. We can do this quad, which is 0, 1, 2. And 1, 2, 3. And we'll see if we still see something reasonable there. And that's also still good. Okay, so let's do both of those in combo now. Ah, fuck. I keep trying to run in that window, but I have to run in this window. And that's also looking good, right? We have two quads there. So we're like on a really good track. Yeah, really, really good track. So let's add in, let's see if we do this like a bunch of times. We don't see any like weird artifacts happening, so it's seems okay. Sorting seems off. Seems possible. Definitely seems possible. So let's see what they had before we started fucking with it. They had 5, 3, 1. 0, 1, 2, 3, 4, 5, 3, 1. So this is 1, or sorry, this is 0, 1, 2, 3, 4, 5. And so we should double check. Are these are not on one of our planes. Because they wanted 5, 3, 1, not 5, 3, 0. So these guys are all negative y, which seems reasonable. Obj indices start with 1. Good eye, good eye. That would do it. Which would explain why we'd be indexing out of bounds on the end, which would be why there's like some like random vertice that we didn't expect. Random vertice? Singular vertices vertex. Single vertex. Good eye, good eye. Okay. So we could go back to our obj parser and add 1 to each of the faces. So I guess parse face. This should be, each value should be subtract 1 on it. Why doesn't he like this? Maybe he needs this to be specified as a U32 now. Okay. And now our tests will fail because that was not expected. But that's okay. So we just have to fix that. So anywhere we had 1, 2, 3 here, we just subtract 0, 1, 2, 0, 1, 2, 0, 1, 2. Test pass, cargo run. Cargo run with all these garbage params. Hey, there we go. That's a cube. Our Z sorting is totally fucked up. But that's pretty sick. That's pretty sick. Do you ever end up using Rust Debugger? If by Rust Debugger you mean GDB, for sure. If by Rust Debugger you mean anything more like advanced than that, or I guess I shouldn't say advanced. I've always struggled with like debugger GUIs on Linux because they all wrap GDB and they all kind of do it shittily. I've always found that like they will probe a lot and not necessarily in like an efficient way. So sometimes your program gets like stuck, and there are like features of GDB that I access through the command line that don't work the way I expect them to. So yeah. Wait, is there none? I mean, I think GDB is like a very capable debugger, so I would consider that. Yeah, I just use GDB directly with C++. Animation triggers my OCD for some weird reason. Oh, is it because it's like fucking wrong? Like, because that would do it. Oh, the maze one. Oh, in like. Okay, what do you mean by triggers your OCD? The maze, you're just like you get like too fixated on it, or like you don't like it. It's like making you feel uncomfortable for some reason. Weird. Is it because he keeps turning the wrong way? It's amazing. Yeah, I mean, I think that's the draw. You look at it and you go, hey, I could do better than this stupid fucking computer who's randomly picking directions. Yeah, I mean, I think that somebody's saying that they keep staring at it, which means it's just like kind of it's doing its intended purpose, which is keeping your eyeballs engaged if you get bored of programming. Okay, what was I doing? I was gonna fix the depth stuff. So somebody said you probably need GL depth test and GLELS. Yeah, I know. I just hadn't got there yet. Come for the EGL, stay for the maze. That's right. Okay, so somewhere I just set a bunch of like GL functions here. So we'll just say depth. What is it? There's like a way to like set opengl enable depth testing. They say I need to clear the depth buffer. I need to enable the depth buffer and set the function that I care about, depth mask. Oh, I see. So we would like sometimes say don't write to that. Yeah. So the idea here, just for anybody who's like not super OpenGL familiar, is like what happens when we run our vertex shader, right? Is we have like a triangle here, boom, 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 and we have like a triangle back here, kind of like behind it. And the order that we draw these guys in is like totally undefined, right? Well, it is. I'm not sure if it's defined. We're definitely drawing them in unorder. Right, like we're iterating. We have like asked it to iterate over indexes of vertices and draw triangles associated with those. I don't know if it's guaranteed that we'll run in that order. It might be. But as we like rotate this cube, like we're kind of like rotating it like this way. We're drawing the vertices in the same order, but like after a 180-degree rotation, all of a sudden, if we were drawing this first before, we'll be drawing it still first. When it's, we want it to draw first when it's behind, second when it's in front, right? Because if we were to just draw without doing any depth testing, the last thing you draw is the thing that would stay on top. So what we have to do is like right now, what happens is we run our fragment shader, right? And we go pixel by pixel and we like store that in our like image, right? And so like OpenGL will like draw one triangle in the image and then just draw the other triangle in the same image. And so by saying like enable depth testing, essentially what you're doing is you're making like a second picture that OpenGL renders. And in here, instead of drawing like the color, he just stores his like Z value in here. So he'll say like, this guy is far. And then he'll try to draw this and he'll go like, is this closer than far? If it is, then I'll like draw it and I'll update far with like close. And he'll do that for every pixel. And so that way he'll know not to run the shader for things that are like behind other things. And so what that like OpenGL thing was telling us to do is essentially saying like, hey, first of all, enable that buffer, right? Like say, hey, don't just draw color, also draw depth. 2, check when you reset your frame, like in the same way that you clear out all of the background for color, clear out all the depth as well. And that's it. This guy's saying like also you could like theoretically turn it off in some cases if you want to. But it doesn't really matter. Okay, so GL enable glow depth. What is it? Depth mask. GL depth mask. GL enable depth test. Oh, and then the last thing is you can set the function. So depending on like your coordinate space, you can ask OpenGL to like say, hey, I've decided that far things are negative values, or I've decided that far things are like positive values, and you get total control over that. So you have to tell OpenGL which one of those you're using, essentially. So here I probably want. I think I have close things as I don't. It doesn't really matter. We'll figure it out. I don't know which one it is, so we'll just pick one at random, and if it doesn't work, we'll flip the other one. So glow less, I think, is what we want right now, but I'm not actually positive. And then here, we also want to clear the depth bit. Glow depth buffer bit. I think that should do it. Bing, bang, boom. Look at that. Look at that. Isn't that pretty? Binary depth buffer is some kind of use of the stencil buffer. Drawing equal as well can be useful for some rendering techniques. Yeah, that makes sense. What's a stencil buffer? I assume that this is like just a fancy name for like extra data. Oh, data buffer. In addition to color buffer and Z buffer, focus on modern graphics hardware. The buffer is per pixel and works on integer values with a depth of 1 byte per pixel. The Z buffer and stencil buffer often share the same area in RAM. Stencil buffer is used to limit the area of rendering. Blah blah blah. Oh, so you can like mask stuff off that way. When would you like write to this guy? Who outputs the stencil buffer? Do lack of precision of the Z buffer. Blah blah blah. Not sure. Not sure. And I don't feel like reading too much right now, but looks like I assume that you would maybe do like a pre-pass of something. And no, I got nothing. OMG, no way I found you. What do you mean found me? Who are you looking for? Like, why are you looking for me? Who do you know me in real life? It's useful for LNs and stuff like that. I understand like the use of the stencil buffer. I'm more confused about like who writes to it. That's more what I'm curious about. But not enough to actually do any reading. Right? Reading's hard. Oh, you watching on YouTube? Nice. It shouldn't be that hard to find me, by the way, if you're watching on YouTube. There's a link in every video, so I hope you weren't struggling, and the name is the same. I think no way I found you is a little bit of like an overstatement, right? It should be like, oh, that was exactly as easy as it should have been. Okay. So I guess now that we can render a cube that Blender exported, let's put a monkey out there. Let's just, let's give us a Suzanne. Mesh monkey. And we need to scale it down so that it's not too big. And export as an object. Bump, 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 bump. And we'll call it cube.object because that's our only thing right now, but we'll fix that later. Hey, that's Suzanne. I forgot to fix triangulation, so we'll just triangulate before exporting. Export, wavefront, export. No? Did I not? These are all triangles, so there's actually probably a bug somewhere that we didn't notice. So export as an object. Apply modifiers, triangulated mesh. Export as cube.obj. Cargo run. Oh yeah, there we go. There we go. That's pretty sick. Pretty sick. Pretty sick. Yeah, all right. That's pretty cool. Pretty cool. What time is it? We're an hour and a half in. So I think that's probably enough to continue with something else. So I would like to get onto like better matrix transformations. So right now we're kind of like fixed with this, like object is in the center of the world. Or I guess in this case, now that we've done our object import, the object is like fixed in its own object space, I guess. We can't like move it or anything. We can do this like one rotation around 0, 0, 0. But that's like the only thing we can do. And we can only rotate it around like the z-axis. So we kind of built up this idea of rotation matrices in 2 dimensions. Right, so and we kind of built up this like this guy here, right? Like you can like do a rotation around, if this is like z coming out, you do this rotation by applying like some sines and cosines to x and y, right? And you get like the new x and y out of there. And so the extension of this idea is that you can rotate around any axis if like, well, I should say it's very easy to apply this to any of the 3 major axes by just putting this into like a 3x3 matrix, where you say like, say I wanted to do x and y and I have a z value here. If I just do this same 2x2, but extend it so that I put a 1 over here and zeros like this, what will happen is when I do like the vector matrix multiplication goes by like essentially this guy gets multiplied with these 3 values, y gets multiplied by these 3 values, z gets multiplied by these, and you add them up horizontally to get the new ones. So you would get like cos theta x minus y sine theta plus 0 times z. Like you essentially put these guys here, x, y, z, z, y, x. And so what happens if you do it this way is x and y have no impact on like the z value because they're multiplied by 0, and z has no impact on the x and y values because they're multiplied by 0 as well. So you can do the same thing around the other axes by just kind of like figuring out which one of these 3 that you want to be 1, right? If you want x not to apply, you would put the 1 in the top right corner and then move all of these guys down a little bit to the right. And so you can just like turn this into a 3x3 matrix that has 0, 0, like this, 0, 0, 1. And this is just the same thing we had before. This is our like initial z rotation. And that means that we should be able to spin in any axes or any axis without anything changing here. So here we'll say our out vertex xyz is equal to this thing times xyz. And oh, I think probably my rotation matrix upload is broken now. So in our cube renderer, before we were constructing this guy as a 2 float matrix. So we'll just update this to be a 3 float matrix and do the same thing here where we put a 0 here, a 0 here, and go 0, 0, 1. Russ is going to get mad because all of these guys should be floats, so we have to put 0.0 F32 everywhere. Cool. Which now looks like it's working again, except our axis of rotation is not what I expected. Because before we were rotating around the y-axis and now we're rotating around the z-axis. That makes sense. And now we can start getting into some of the fun parts of like these like rotation matrices. So where these get like really powerful is we have one rotation matrix that applies one rotation. But you can actually like, because of the way that the math works out, where essentially you have like your matrix and your vector. If you like stack another matrix over in the corner here, the rules of matrix multiplication make it so that if you multiply these 2 matrices together, it's like you did the 2 actions back to back. You get the same thing as if you did like one then the other. And so you can actually you can do stuff like say, first I want to rotate around the x-axis, then I want to rotate around the y-axis. And I can do both of those at once. And you can like do these like matrix multiplies to turn these into like a single transform. So I guess we probably, to start to like implement that, it makes sense for us to do that on CPU, not on GPU, because all vertices get that same matrix multiplication. And so like it makes sense to do it on GPU because you might have like thousands and thousands of vertices all done by one transform. But that one transform is like for like an object as a whole. So doing that on CPU is pretty reasonable, which means that we need to do matrix multiplications on CPU. Sorry, we need to like implement a way to do matrix multiplications on CPU. So I don't know. I guess we'll make a matrix type, and we'll say struct mat. I guess we'll call it. And for now, we do need 2 dimensions probably. So we'll say const n or const x and const y. Is this how I want to do it? Think of using the columns as a result of the matrix being acting on the basis vectors. It would make even more sense. Think of the matrix columns. Matrix columns as a result of the matrix action. Oh, yeah. That does make sense. Nice. Yeah, because like each column of the matrix corresponds to one of the XYZs. Is that correct? Isn't it each row? Am I flipped? You're saying that if I have like this times 1 0 0, first column is done to that guy. Oh yeah, I see what you're saying. Yeah. Like so if I have a rotation here, my new position after that rotation will be like non-zero. It'll be like A, B, C. If I had like A, B, C in here. And that's like, yeah, that makes sense. I guess when you say like thinking of it how the matrix acting on the basis vector, I was thinking like if you think of it as column or as the row, you get like new. Oh yeah, you're right. This is the rotation of new coordinate relative to original coordinate in this column. Yeah. You're right. I get you. And then there's something about like all of the rows and columns adding up to 1 to make the scale the same, and you can like scale things by increasing that and like add skew and stuff, but we'll get there later. That's pretty funny. I have my stream start screen still up, and it says stream starts in -1 hour, -42 minutes, and -54 seconds. That's pretty fucking stupid. Okay, so we need this matrix to have an x and a y dimension. I wonder if it makes sense for this to be yx or xy in this. I guess we'll just make it xy for now. Yx is so much easier to think about in programming because like you want like contiguous x. So in this guy, we're gonna say that the value is like, you know, floats for x, and then we're gonna have array for y. I don't know if this is like doing this generically will make sense, but we'll kind of figure it out for now. We'll start with this and we'll see how well that kind of translates. And we'll throw an implementation at this. And what are we going to say? We're going to say we want some way to like multiply these matrices together. So we could actually probably implement the multiply trait, which seems reasonable. Mul. So I say if I want to multiply, I say that I multiply by the right-hand side. I wonder if this will do right to left multiplication, if this handles this. I don't know if like Rust assumes that if I multiply, left times right is the same as right times left, because in this case it's not, and that's going to be important. But it looks like they do expect a right-hand side. And the right-hand side could even be a different type. And it doesn't... I guess, like, if I were to implement this multiply operator, I would kind of be implying that it's the same as, like it's kind of like an implied... It's implied that it would behave the same way as a regular multiplication operator. And that's, like, kind of true in that in math, the multiplication operator does behave that way. I don't know. It's kind of weird that it's asymmetric. But fuck it. Fuck it. Also, the sizes have to match. Yeah, so I think you can do a... They have to, like, match... They have to be, like, inverted, actually. But I guess you can kind of, like, enforce that with the type system, I think. We'll see. Impl stood ops mul for mat. And here we have yx, and he's yx. When you do, like, matrix multiplication, like, the dimensions have to be flipped for the other... Like, hold on. Like, if you have a non-square one, like, you know, like 1, 2, 3, 4, and you only have like 2 rows, 5, 6, 7, 8. You can only multiply this by like a 4 by 2, if I remember correctly, right? Like you would have this to be like 1, 2, 3, 4, 5, 6, 7, 8, because you're doing like column times row. Am I misremembering? Matrix multiplication. Yeah. So yeah, like they have like 3 by 4, 3 by 4. You multiply m by n and n by k, and you get m by k. Oh, yeah, I see what you're saying. Yeah, you're right, you're right, you're right. You're right. So I just need to make sure that my number of... Yeah. So one of the dimensions needs to match, but not both. So my x needs to match my y in the second one. Maybe you only ever need 3 by 3 matrices. Well, I know that I'm going to build up to 4 by 4s. But yeah, maybe... And I'm also going to eventually need 4 by 3s for projection. I think. Am I? No, because I'm only going to use these for transforms. You know, we can make this whole thing a lot simpler if we just call it transform for now and just force it to be a 4 by 4. Or we'll start with a 3 by 3, I guess, and we'll turn it into a 4 by 4 later. So we'll call this rotation matrix. And we'll impl multiply for rotation matrix, and that'll make everything easier. We're getting too generic too quick. Too complicated too quickly. We should build it up as we need it. Okay. So the output is self. We have a mul operator with the right side, and we just have to say for I in 0 to 3, for j in 0 to 3. Too quick into developing a full-blown linear algebra library. Exactly. We do let output is a rotation matrix new. So here we say we have an implementation of rotation matrix, and his new function will output a rotation matrix, and his starting value will just be zeros everywhere. So here we say 0.032 by 3 of them and 3 of those. Okay. So for each value, we say that we say output I j, or sorry, we'll use y and x to make it easier in my head. So output yx is equal to input, or the left-hand side, y... fuck. Let's think about this. So we need to basically multiply the row by the column of the second one. And that is the first element. Yeah. So, we say self array y x times right hand side xy. Am I crazy? This is so hard to think about. We need to draw it out. We have array 1, array 2, and we have output. We have, this is for x, y, we're going to multiply by x 0. We're going to go 1 times, let's put letters, A, B, C, D, E, F. A, B, C, D, E, F. So we're going to multiply A by A, then A by D, then A by whatever's down here to get this value. Which means that if we're going to loop that way, we're going to say we have our x coordinate and y coordinate, and we're going to have to loop over the whole row for the first one and the whole column for the second one. Right. So our left side is self. So we're going to self dot array, and he's we need like a new loop variable, I guess. Yeah. For I in 0 to 3. Here's what I was missing. So the output y x is equal to the left-hand side, which is going to be fixed to the row. So the row is going to be y, and we're going to iterate over the row on the left-hand side. On the right-hand side, we're going to iterate over the column. We're just going to do the other one. So we're going to say array I x. And here, we're going to say the output plus equals that. I'm pretty goddamn sure that's right. We have to unit test this. Clueless gifted a tier 1 sub. Thank you. Appreciate it. Okay, so let's throw a test at this guy, and we'll just see if we can have a sample that we pull from somewhere. Or maybe we'll pull in. Wait, here's what we'll do. We will open Python and make sure that we have NumPy installed, and we'll just do a matrix multiplication over there and check that we get the same answer. NumPy NixOS. I think there's like some package for it. Nix package search. And we're going to look for NumPy, which I just say Python 3 packages dot NumPy. Give it a second. We're going to open Python, and we're going to say import NumPy as np, and we're going to say a is equal to mp dot array, and we have like 1, 2, 3, 4, 5, 6, 7, 8, 9. This is our first array. A. Boom. We have B is going to be the same thing, but 2, 3, 4, 5, 6, 7, 8, 9, 1. And then we have A times B, and we'll just see if we get the same answer. Easy peasy. So we'll say, what program do you use to use Python? Python. It's like an interpreter, so I don't need to like you don't need to use like a specific program. Like running Python on a Python script, like Python is the program and the language, if that makes sense. Just like here. That's all we did. Okay. So let's say test simple mul. and we'll take in these two arrays. So we'll say, I guess, do we want to make like a fancy constructor function? Nah, I don't get. Do I? Nah. Did you mean which IDE? That's possible. Oh, do you mean probably meant what program you use, like Python running on my machine? I wouldn't trust. So if you're new to programming, yours is just a black screen and the idle. Yeah, I guess the answer is going to depend on your operating system. Probably, looks like you're probably on Windows. I would guess black screen and the idle. Yeah, I'm not sure. Not sure. I think that on Windows you might have like some like different default behavior. Not 100% sure about that. I would have to poke it and prod it and see. Okay. So let's see. We're gonna make our left-hand side is just gonna be the same thing we did here. So we'll just copy paste these arrays. So say let A is a rotation matrix with array. I'm running NixOS, which is great for me. I don't know if I would recommend it to everyone. But it's kind of like if you wanted like a config file that defines your OS, that's kind of what like Nix gives you, as well as like they promise like build reproducibility and stuff, which is kind of neat. It's like if you want like multiple versions of Firefox running on your desktop, Nix is like great for that. It has like this like whole like separation of dependencies thing going on, which is pretty cool. But all of that stuff comes with like complexity, right? So if you just want like an operating system that works, and you run Ubuntu, you're gonna be like sorely disappointed when you come over to the Nix land. It does just work in some ways, but like, yeah, it's complicated. Doesn't run binaries from other distros. Yeah, because like binaries will like have hard coded that they expect a file to be in like user bin bash, and that just like doesn't exist, right? If I say like which bash, it's like in like this like weird fucking path in this like Nix store, and so like every package that you make with Nix, you have to like patch out stuff to like make it look for the right things. There's a lot of like pain that can come with it, but if you just use like supported software, then it's like not too bad. Let's see, is equal to A times B. More about libraries rather than bash. Yeah, patch elf. But I guess like if you have right, like if you like export an executable with Godot, it's gonna hard code like user lib ld.so or whatever the fuck it is. The like, yeah, and they're dynamic linking. Yeah, okay. Same shit. Or like they might have like app images might have bin bash hard coded. A lot of scripts that you download from the internet will have bin bash hard coded at the top. It's a bit of a pain. It works. Okay, so we have this multiplication, and we expect the answer to be whatever we saw over here. Womp. So again, these are floating point, so we're gonna have to be careful about comparisons here. So we'll say for y in 0 to 3, for x in 0 to 3, we're going to look at A, B, and C. So we're going to say, or no, we're only going to look at C. Sorry, we're going to say expected is equal to this. This guy, like this. Is the final boss, the Windows 95 button, ever appear on the maze? There's a gray wall that has nothing on it, but not the real final boss. It will eventually hit an end, and there's this like kind of like Star Wars shitty transition where it like does like a little screen wrap. It's like a 16 by 16 grid where there's a final answer, but eventually, yeah. If you watch. The real bait would be if I said that there was one and there never got like there wasn't, and I said stick around to watch. But I promise you there actually is an end. Okay, so we're gonna iterate over all these things, and we're gonna just check that the values are what we expected. So we'll say if assert that expected y x minus what we calculated y x, and we absolute value that is less than some epsilon. Okay, cargo test. And that's not marked as a test, so it didn't run? Oh, it does. Maybe we're not included? Probably we're not included. Mod ban. Okay, now we're seeing all sorts of fucking errors. Sick. So here we've got to return output. This needs to say array on it. And other than that, looks like it's working. Expected.array. So the expected doesn't have an array field. He's just a two-dimensional array back to back. And abs is on an integer, which is also annoying. So here we need to say all of these guys need to be converted to floats. So we'll just say that this is a slice of F32 arrays of 3 or something. F32 3, F32 3, and maybe that should autoconvert. Doesn't like that. So I guess I can just say .o F32 everywhere. I'm surprised, like, I don't know why the other ones aren't yelling at me, but it is what it is. Rotation matrix, oh, because rotation matrix doesn't exist. So we'll say use super everything. Are you good with math? I don't know if you're asking me or you're asking the guy who's asking if programming gets any easier. Me? Not very. Programming definitely does get easier. Yeah, it's like learning a language, right? The more you practice, the more you do it, the more things will just come second nature. Yeah. I don't know, if you're just starting out, like, I would... Wait, you were literally doing linear algebra? Yeah, but it's like, I'm up for it. I'm struggling. You know, all this is just multiplication, right? It's not great. And like high school algebra, high school trig, it's nothing too crazy. Once you get into like calculus and stuff, I'm lost. Eventually, I want to implement a neural network, and I know that that's going to cause all sorts of fucking pain. Okay, so confirm that this test fails if it's not expected, and confirm that the multiplication we just implemented is great. Needing 0.032f is so extreme. Rust really doesn't want you being productive. I mean, I will say that all of the pain points that come from Rust like that is it's also where it shines, right? Like automated type conversions in C, where like, dude, when like things just like cast from like doubles to ints and like nobody tells you, that's fucked, right? That's like, I've hit so many fucking bugs because of that type of shit, and it's like, I would way rather Rust yells at me and make me type a few extra characters than the alternative of it not telling me when I'm doing casting when I don't want to. Calculus is differentiation is just division. Yeah, that's true. Yeah, especially when you're working with like discrete, but I don't know. It's still hard. I don't know. Okay. Okie dokie. So this is working, and now we can go back and we can go back to our cube renderer, and we can try stacking two rotations, right? We have this like rotation around the z-axis, and we can now convert these. We can like say, now I want to also rotate around the x-axis, and we can stack those together, and we should see some sort of like combined rotation, which is really all I was trying to get to. So let's say here, we'll construct this guy now as a rotation matrix. So we say use our crate mat rotation matrix, which I guess it's probably not liking because it's not public, so we'll just throw that a little pub on that guy. I guess we'll also need to public the inside for now. This isn't really what we should do, right? We should make some sort of like reasonable interface that like gives us back something that we care about, but for now we'll just make it public because we're trying to cut corners. We're going to construct our first rotation as this guy, whatever we had here, and we're just going to say let rot1. I guess we have to, right now we don't have any like nice constructors for it, so we're just going to say rotation matrix new, and rot1.array is equal to this guy. Function new is not public. Yeah. So we fucking throw a little pub on there. We're missing the close bracket, sure. So a little bit of this guy, and then we need to put some extra 2D-ness on this guy. So he doesn't like something on here. What the fuck? Oh, it's because we said let here. And this has to be mutable. Okay, then we'll put in a second rotation that we're just going to do the same thing, but around a different axis. So we'll say maybe we'll do the x-axis for the other one, or the y-axis. Let's do the y-axis. So for the y-axis, we need this to be 0, this to be 1, the sign, this to be 1.0, this to be the other thing, and here we need to swap these columns, I guess. Yeah, something like this. Something like this. I don't know. We'll see. I'm just kind of like spitballing and we'll figure it out. This looks about right. This looks like you have like things applying to X and Z and nothing to Y, which is what I'm looking for. So this is going to be rotation 2. And we'll say the combined rotation is rot 2 after rotation 1. So we do right to left, I think. I'm actually not sure. And here we will pass in this guy as a slice. So we'll say combined.array, and we'll throw a little ampersand on him. And if we did everything right, fuck, we need to do some like slice casting. Fuck. So we do combined core stood slice from raw parts. We take the combined array and we cast it to, we take its pointer and we cast that pointer to a const f32. I guess we take the combined array 0, 0 as a pointer. Yeah. So we do this guy, take the first element, and then we say his size is actually going to be 9. And hopefully that actually works out. I don't know. That looks about right. That looks about right. And now we cargo run. Hopefully we see like, yeah, there we go. See, we see like some sort of like 2-dimensional rotation going on, right? He's rotating around the like vertical axis in the world, as well as rotating kind of like around his nose, which is pretty cool. Yeah, I'm happy with that. We didn't get as far as I thought we would get on like transforms, because we kind of got sidetracked by obj parsing, but yeah, overall pretty sick. Probably next stream we'll kind of build up the concept of translation and to do some like texturing, right? Like this guy looks kind of fucked up right now because he's just like white and pink. So I want to like throw on like textures as well as maybe eventually I want to get to lighting. So we'll get there. For AI, there's a really good depth and tutorial on neural networks by Andre Kaparthi. Good to know. I'll give him a look. Keep at it. This is how you learn. Yeah, for sure. Yeah, if anybody is ever like struggling with programming, just keep going. That's what we're doing on this stream. Is like we're like implementing an OpenGL renderer, which is like, why the fuck would you ever do that? There's no reason to do this, right? Every like sane person who's trying to get something done would use the game engine, but by just like trying stuff, keeping on going, typing some code, eventually you kind of like pick up pieces and learn stuff along the way. So for sure, should just do Vulkan instead. Vulkan sounds hard, but I do want to do it one day. So I'll probably start with an OpenGL one, and I want to eventually get to like a Vulkan ray tracer at some point. Yeah. Okay. So I think I'm gonna call it here. We're just over 2 hours. If you liked what you saw, I stream most days at around 1 or 2 Pacific time. I'm not gonna stream tomorrow because tomorrow's fake Christmas with my family. But I'll be back on Monday, and we'll be back on probably doing like some sort of like texturing and lighting and stuff. And translation. Yeah. There's a YouTube channel linked in the Twitch description, so if you're don't catch me live, but you still want to see what we worked on, all VODs go up on that YouTube. There's a GitHub linked in the Twitch description. I probably should push this guy to that GitHub. I probably will soon, but he's in like kind of like a really fucked state right now, so I don't like all of the code's kind of something that I'm not proud of yet. So I try to make sure that like each commit that goes up is something that if somebody looks at back in the future, they can like see it and be like, oh, that's a chunk of work that makes sense, and like I could learn something from that. And by learn, I don't mean like somebody else necessarily. That someone else could very well be me. So I want to make sure that like my commits are logical chunks of work, which means that sometimes things get delayed getting put up, but whatever. Yeah. Otherwise, thanks for watching. Oh, we got a couple more questions. Are you planning on writing Rust professionally someday? I try not to plan, which is like kind of stupid, but I'm of the opinion that one, specifically for this, I don't think language matters, right? Right. If you're writing Python, you're writing Rust, you're writing C++, it's all the same, right? And what we should really be focusing on in terms of like career would be just making sure that we're like advancing as programmers as a whole. I would like highly suggest trying languages in general, just so you like get ideas. You think it does? I mean, I think that anybody who's like if you're a competent programmer in a couple languages, you should be able to be a competent programmer in all languages. Would be like what I think. Obviously, that there's like intricacies to each of them, but like once you've hit a couple, like you should end up understanding the patterns. Different communities going up different paths for the same problems. That's definitely true. But I think that like you're like the job of somebody who is programming is to be able to understand what is there and adapt it to what they want, right? So if two people are going on different paths and you get plumped into both code bases, you should be able to I think you should strive to be able to work in any of them, is kind of what I would argue. Obviously that's like there's a limit to every human's ability to learn and whatever, but yeah, I get what you're saying. Like, you might prefer working in one language because of the way that the community is set up. Yeah, that makes sense. Sorry, I got sidetracked. I was trying to stream. So, thanks for watching, guys. I'll catch you guys on the next one. Bye!